In this video we will talk a little bit more about running your first playbook and everything that's involved. So to run a playbook you use the Ansible playbook command. And syntax check is possible, but it's not really needed. And that is because the Ansible playbook command will alert you anyway if anything is wrong with your playbook. If you want to get more insight in the workings of the playbook, you can use the -v option, up to 4 times for increased verbosity messages. -v 2 times will tell you which files are used, which is pretty convenient. And -v 4 times is giving you complete debugging information about everything that is happening while you are running your playbook. Notice that by default playbooks do not write any output log. You can read the standard output, which is your computer screen, to analyze the messages about success or failure of the playbooks. The idea is that in the command line version of Ansible, also known as Ansible Engine, output messages are printed on screen. You can read them from screen. So why would you want to write them to log? Because logs can be very verbose. Now let's go have a look at an example playbook. There is install and start httpd.yaml. You can find it in the basics directory in the Git repository. Let's go check it out. So in the Ansible CVC Git repository, there's the basics subdirectory. But hey, before we continue, let me show you history, pipe, grep, git, just to make sure that you see where I get this from. So command number 87 is telling you git clone, https://github.com, Sander van Vught, Ansible CVC. That's the course Git repository. In there you will find install and start httpd.yaml. That's the example playbook. So install and start httpd.yaml. About the name of the playbook. Playbooks are written in YAML and it's common to have the YAML extension. And you can find 2 different extensions. You can find YML, you can find YAML. For some reason I like YAML better, and that's why my playbooks in general have YAML. But it's totally fine if you want to do YML. It really does not matter. So here we can see this install, start and enable HTTPD. So it's a different playbook doing the same thing as what we've just seen. It starts with 3 dashes. That's a YAML identifier that is telling your YAML interpreter that the code is starting here. Then we see the play header. So this is a one-play playbook. And in this single play playbook, we are running it using name, hosts, all, tasks. Are we going to do this on hosts, all? No, we shouldn't be doing that. Let me use hosts, Rocky. For the simple reason that Ubuntu does not have a package with the name HTTPD. Oh, you know what? Let's talk about errors at the same time and let's try to run it on Ubuntu as well. So next we have the task, and in the task I'm using the package module. Package is a generic module that allows you to install software packages. It doesn't allow you to use some of the specifics that may be available in specific modules like apt and DNF, but the nice thing about it is that it will work against different Linux targets. So this is going to try to install the HTTPD package, and then it is using the service module, and in the service module it will try to make sure that the HTTPD package is started and enabled. So package talks to the package manager on the backend of the managed target, and service is talking to systemd to make sure that the package is installed. Now let's run it. Ansible playbook is how you run it on install and start httpd.yaml. And there we go, and we can see it starting with a fact gathering. Fact gathering always takes a little bit of time. We just talked about it. And fact gathering is something that actually you may want to turn off, because facts can be used as variables inside your playbook. But if you're not going to use the facts, why would you waste the time on gathering them? You can see that here reaching out to the Rocky machines is taking some time. And, oh, what do we see? Install package fatal, Ubuntu failed. So what is it showing us? Well, if you glimpse over it, we can see that the package HTTPD has no installation candidate. That makes sense, because on Ubuntu the name of the package is Apache 2 and not HTTPD. You can see on Ansible 1 as well as on Ansible 2 we get a status of changed, which means that the package has successfully been installed. Changed means that the desired state, as described in the playbook, did not meet the current state of the managed machine, and a change was required. If the desired state already met with the current state, then you will see OK instead. Also, you will see something else. In Start and Enable server, it's not working on Ubuntu anymore. And that's because of the default behavior in errors. If task execution on a specific host is failing, then further task execution on the same host will be skipped. So that is why Ubuntu failed in install package, so it doesn't play ball anymore in Start and Enable service. And we only continue on Ansible 1 and Ansible 2 to start and enable the service. So in the summary, we can see that on Ansible 1 and Ansible 2, 3 tasks have run successfully. If you are wondering why is that 3, that is because fact gathering counts as a task as well. Of these 3 tasks, 2 have triggered a changed, and one of them is only an OK. And on Ubuntu, well, on Ubuntu, fact gathering was working as expected, but we got a failure. And that's why we see failed is 1. Now, it would be interesting to run the playbook again. If you run the playbook again, it should give you the exact same result, with the exception that now Ansible 1 and Ansible 2 already have HTTPD installed. So now we should see the idempotent nature of the playbook. It shouldn't do anything, it shouldn't complain, it should just tell us OK and OK, because no further changes were needed on Ansible 1 as well as on Ansible 2. And that is exactly what we see here. It's still failing on Ubuntu, that's expected behavior. And then we can see that on Ansible 2 as well as on Ansible 1, it is giving us an OK. OK meaning that the managed machine state already met with the desired state and no changes were necessary. Right, now that we have run and analyzed our first playbook, let's get back to the slides and see what else is in there. So we have seen how to run the playbook with Ansible playbook install and start httpd.yaml, and how you can observe the output. We've also seen that different things are happening while executing a playbook, which includes fact gathering, task execution, and a play recap. And notice that good playbooks are written to be idempotent. Idempotency is really very important, because you want every single time that the playbook is running, no matter which is the state of the managed machine, you want it to be successful. Now in a playbook, you can also find multiple plays. That's the nature of a playbook. It can define one or more plays. And defining multiple playbooks makes sense in a couple of cases. First, to write the playbook in a modular way. Just imagine that you want to set up a host and there's like 50 different tasks that you want to run on one host. Then including all of the 50 tasks in just one play is not really easy to manage dependencies, to oversee what exactly is happening. And you might be better off, just for the sake of organization, to make it a multiple play playbook. That would limit the number of tasks that run in one play. Also, another good reason to run multiplay playbook is to run some tasks on one host while others are running on another host. Or if you want to, in a play header you can set variables as well. Multiple plays allows you to work with different variables in different stages of playbook execution. Now let's have a quick look at run and test httpd.yaml, which is a multi-play playbook. So here we have the run and test HTTPD. So what do we see? We see that it is installing and enabling HTTPD in the first play. Then we see gather facts is set to false, because fact gathering is useful if you are going to use the variables that are gathered by fact gathering. If you are not planning to use them at all, you might as well turn it off. The host is Rocky, so we are going to run this on Rocky only. And what do we see? Install and start and enable service. This should give us OK and OK, because the service is already installed. And next we go to localhost. Localhost is your Ansible control host. We do not need to become anybody else, and that is why become is set to false. We can do that with ordinary user privileges without any privilege escalation. And we are going to test HTTPD accessibility. We do that by using the URI module. And the URI module is going to reach out to the URL http://Rocky. And if name resolving is set up correctly and HTTPD is listening and the firewall is open as well, well, then we should see positive reaction. Let's run it. Ansible playbook on run and test httpd.yaml. As you can see, we are skipping the fact gathering. That makes it really much faster. And then it's trying to install the package again. That's something that's not needed anymore, because we have already done that in the play that we were just running. But the thing is that behind package management, there is yum/dnf on recent Red Hat that needs to update package cache and stuff like that. And that always takes a minute or so. So there we go, start and enable service. That also should not take too much time. And now we can see that we are executing the second play. So at this point we are on localhost, on which, by the way, I forgot to turn off fact gathering. Of course, we don't need any fact gathering at all on localhost because we are not using it. Next, it is working on test HTTPD access. And oh no, what do we see? Well, we see changed false content elapsed status code was -1 and not 200. The URI module is expecting a status code 200 if access is successful. It was not successful. And why is it not successful? Well, most likely because we are not doing any HTTPD in the firewall here. By default, the firewall is preventing HTTPD from being accessed. You know what? Let's fix that right now. I'm going to open a new tab. And in my new tab, I am going to use Ansible doc on firewall D. Firewall D is the module that we need on Red Hat and related. I am going to scroll downwards, and if you scroll downwards, we can see an example of what we need. So let's get back to the other tab, and on the other tab, let's use this run and test HTTPD, in which I am going to use name, open, port in firewall. Firewall D is what we need. Notice that Firewall D is specific for Red Hat. It won't work on Ubuntu, but that's no problem here because we are on the Rocky hosts anyway. And then what do we need? Well, we need to follow the example, which is service permanent state and also immediate. So service permanent state and immediate. So service is going to be HTTP. Permanent is going to be set to yes. State is going to be set to enabled. Is that true? So we will double check in a while. And immediate is going to be set to yes. Let's double check, and service, permanent and state enabled, all looking good. Now, how about the immediate? Do we see that in the examples as well? As you can see, I really like the examples, and the last example has the immediate. And that is exactly what we need. Immediate in Firewall D ensures that it is immediately opened. And we don't need to wait for the next restart of Firewall D. All right, now I can get back to my playbook and I can include this gather facts and set it to no. Notice that this is Boolean. And in Boolean, you can use false, you can use no, you can use false with an uppercase F or a lowercase f. Ansible is quite tolerant relating to all of that. And now we are going to run it again and see what it is doing. So there we go, it's opening the port in the firewall. As you can see, changed and changed, which means that the firewall port is opened successfully. And now it's testing HTTPD access, and once it's done, it should tell us that it got a 200. 200 is the HTTP return code that is identifying that all was good. And oh no, we can see that still HTTPD access is failing. What is going on? Well, let's use some ad hoc commands to troubleshoot. So I'm using Ansible on what? Well, I know what is going on. Let's have a look. Can you see what I'm doing here? I'm using HTTP on Rocky. I shouldn't be using HTTP on Rocky because Rocky is the name of a host group. And we need to do this on a host itself. And that is Ansible 1 instead of Rocky. Let's run it again, and once it is there, and now we should see that it is successful and giving us the result that we want. So what is this? This looks like an error. It's not. This is the default web page that Apache is showing if it does not really have anything else to show. It's not an exit code 200, and that is why we see this message failed. But if you know Apache, then you know that you shouldn't consider this a failure. This is doing okay. The thing here is that we get status 403, which means index HTML not found. And that is why we see this. Troubleshooting, we don't need to troubleshoot this. We can consider this a working situation.